Okay, last time we looked at sine and cosine sum and difference formulas. Take a look at the proof just so you can see where it comes from. You don't need to have these guys memorized, just be able to find them on your note cards. Notice they use U's and V's instead of alpha and beta, or even an A and a B. Just understand what corresponds to what. Today we're going to look at some different properties with them, and then also get to those tangent equations that we ended with last time. So last time the problem was like tangent and 19 pi over 12, I think. And the main idea was we just talked about what can we do with a 19 pi over 12, okay, but you didn't have a tangent formula to actually look at. All right, here's what they're going to give you in the second half of this. So they're going to tell you sine of alpha is 1/2, and they're going to give you a quadrant. Okay, so we don't have to worry about inverses or anything. They're going to tell us where this is. They're going to give us cosine of beta, so it's important to keep these guys separate. And beta is going to be in a different quadrant. They're going to want you to do a couple different things here. Okay, so first thing, whenever I see one of these, is I put my triangles in. So it's telling me sine is in between pi over 2 and pi. So that's going to be quadrant 2. Make sure you put an alpha here so we know which triangle we have. The sine's 1/2. That means this is negative square root of 3 because that's our special triangle we have. Now, you know your quadrant's also right because sine's positive in quadrant 2, so that works. Okay? Cosine of beta is negative 1/3. Beta is also in quadrant 2 as well. Greater than pi over 2, less than pi. So draw a separate triangle here. Make sure you label this guy beta. Cosine can be a -1, so that's good. So we got to do a little Pythagorean theorem here. So this is going to be square root of 8 or 2 square roots of 2. Okay, 9 plus, well, 9 equals 1 squared plus b squared, or y squared, whatever you want to call it. So there's your square root of 8. Okay. Now, first thing they want us to do is find cosine of alpha. Down here, the book did it with the Pythagorean identity. Okay, sine squared plus cosine squared equals 1. I like doing it off the triangles, but it's up to you guys to figure out what you prefer. So if I'm trying to do cosine of alpha, I'm just going to go right to my triangle, and I'm going to say, let's grab some more room here. So go to the triangle with the alpha, grab your cosine. Negative square root of 3 over 2. Okay. Nice thing with triangles is you never have to worry about signs, whether it's positive or negative, because if you label them appropriately, like we did here and here, the signs take care of themselves. Okay. Sine of beta. So we're going to a different triangle now. We're trying to do the sine of this guy. So we go to this beta, opposite 2, square root of 2 over 3. Okay, we don't need to rationalize, so we're good there. And lastly, they want us to do a cosine of alpha minus beta. Okay, so we need our sine cosine formula, or difference formulas. Okay, there's the second piece. So here's our third piece. Okay, so this is the information we had from the first couple pieces. If you guys are doing these, you'd have the triangle right there for you. So all we have to do is evaluate this formula. We know a cosine of an A minus B. Cosine A, cosine B, plus sine A, sine B. Cosines always have the opposite thing here. And all we got to do is plug stuff in. So these are values we've already used from our triangles. We plug them in. Now notice this guy is a negative times a negative here, so this guy goes positive. You should have a common denominator when you do these. If not, double check your work. I'm not saying it'll never happen, but more often than not it will. Once you see your numerator is the same, this 2 gets multiplied by the hidden 1 here, and that becomes, well, ignore that piece. I guess we can't multiply. I'm sorry. So square root of 3 plus 2 square root of 2 over 6 would be our final answer there. Okay? So there's one piece. They're going to give you alphas, they're going to give you betas, they're going to give you quadrants, some different things to do. So we could also take this, we could do a sine of A plus B or a sine of A minus B. And really, once you have your two triangles, you can do anything you want with these formulas. Okay? So there's one thing. Now, here's these tangent ones. Okay, again, you don't have to have them memorized. We just got to know how to work with them. Notice tangent alpha plus beta. So tangent A plus tangent B, 1 minus tangent A tangent B. Okay, so the tangents, if it's a plus sign here, it's plus up top. It's minus down here. If it's a minus here, it's a minus up top and a plus down bottom, and the formula is exactly the same. Where this guy comes from, if you wanted to look, it's on 478, but basically what they do is they say, oh, if you have a tangent of something, I know a tangent is a sine over a cosine. We have formulas for these. So they write out the sine, addition 1. They write out the cosine, addition 1. Common denominators, some substitutions, make things a little bit simpler, and they get to this guy right here. Okay, same idea for the difference formula. Instead of sine A plus B over cosine A plus B, they just use this. The formulas change a little bit with the signs, not where things are placed, and how that affects it is these two guys get switched around. Okay, so all we need is the formulas. They're on your guys' sheet. You just have to be able to work with them. Okay? Now, they're going to tell you this. Tangent of inverse sine of 12 out of 13 minus inverse cosine of negative 3/5. Okay? So clearly we can see it's a tangent subtraction formula here. Okay? Now, what they're going to do is say, call this guy A, or alpha, call this guy B, or the beta. Now we got to use what we know about inverses before we can even do this. So I left all the stuff from the book here, but I'll show you guys where this comes from as well. So inverse sine of 12 over 13. So they want to know where is the sine 12 out of 13, okay? Inverse sines are only defined in two places. So there's one positive, there's one negative to make that guy a one-to-one function. If it's positive, it's got to be in quadrant 1, okay? So our alpha is in quadrant 1. Here's a 12, 13, and this guy should be a 5. That's just a Pythagorean triple, and you guys can check that, okay? This guy here, where is the cosine negative 3/5? Inverse cosine's defined here and quadrant 2, so we get one that's negative as well. It is a negative 3/5, so we got to be in quadrant 2. So we said we'd call this guy beta, cosine negative 3/5. That means this guy's got to be 4. It's a nice Pythagorean triple. Okay, and that's the same information that all of this is conveying as well. Okay, we know inverse cosines go 0 to pi, quadrant 1 to 2, like we just talked about, and we have our triangle set up. Okay, once we have our triangle set up, we can really do anything we want here. And we'll do that first thing in part 2.